All right, so the reason I like using either videos or these slides better than a conversation is it's a lot easier for me to show you what I want to show you, and then I'm not also having as many internet problems, but with your connection. But let's try it this way first, and if it doesn't work, we'll have a call. So what you're working on right now is any polynomial that's in the form of, so we can say x cubed plus or minus some value of k. And in this case, this value of k is being cubed, but it doesn't really matter. It's still just plus or minus some value. And so on Desmos here, I wanted to kind of just point out to you that these are always going to have this 0 we can see here is what we call a real number. When it's a real number, we see it crossing the x-axis. And there's always going to be one real number. But as you've kind of learned in this unit, that when you have something that's x cubed, it means it's going to have a total of 3 zeros. And in this instance, one of those zeros is real and 2 are unreal. They're imaginary. And on the imaginary zeros, we do not see them on an xy plane. All right, so what we're going to have to do is we're going to have to find the non-real zeros in a different way. So let's kind of look at this formula here as we bring this in. So we're looking at when we have either a cubed minus b cubed or a cubed plus b cubed. There's really no difference, so I'm just going to focus on the a cubed minus b cubed first. And when we look at this, this is the real part that we're seeing up here. So the a minus b, in case it's going to be some x minus value, we're going to see that. And then this part here, we're going to have to use the quadratic formula to solve this. And I'm going to do a real example in just a second. So we're going to have to say that x equals negative b plus or minus b squared minus 4ac all divided by 2a. And we're going to always find that what's inside of here, oops, I don't want to do that. Let's go back. I want to just highlight that. What's inside of here is going to be a negative value, and it means I'm going to have the imaginary number. That's why I don't see the real 0. So let's just pull up one example here that I was looking at on D14. So the example said that we had x cubed minus 27. All right, so obviously in this instance, a is just x because we have some value. For the b value, I have to think, oh, well, what is the value of b? All right, so I have to think what value cubed makes 27? Oh, b equals 3. And so now I'm going to just try to use this formula. A minus b, well, that's x minus 3. All right, now a squared, so a is x, so it's going to be x squared. Now I'm going to have 3x because that's a times b, and now I'm going to have 9. Now this is asking you to solve, so it means we're this over here a little bit, we're setting this equal to 0. So if I want this whole thing to be 0, if I say x is 3, 3 minus 3 is 0, 0 times anything is 0, so x equals 3, and that would be the value. So if I was graphing x cubed minus 27, it would be crossing right here at x equals 3, and it would be doing this going down and coming up part. But now, to solve this part, to figure out where does this equal 0, I know anytime I have this pattern, these are going to be imaginary. And the only way I can find these answers is by using the quadratic formula. So I'm going to say, all right, x equals negative b, that's negative 3. And I know it's a little bit confusing because this b is referring to this value here, and this b is referring to the value in the original formula. So we do get a little confusing with our a's and our b's, but keeping track that they're just variables holding in for a formula. So here we have, this is negative 3, we have plus or minus the square root, b squared is 9, minus 4ac. All right, so a is just 1 and c is 9, so 4ac, that's going to be 36. And I'm going to divide that all, sorry, this is by 2a, so just by 2. So now x is going to equal negative 3 plus or minus, well, 36 minus 9 is 27. All right, and this is going to be divided by 2. All right, so now we just have to remember how we reduce things. So we have negative 3 plus or minus, all right, 27, the square root of 27 equals the square root of 9 times 3. The square root of 9 is 3. And then I'm going to still have this, oh, this is negative 27. So the square root, and then I have negative 3. So I'm going to have an I there for the negative 1, right? And then this 3 still stays inside, divide by 2. And I can rewrite this as negative 3 over 2 plus 3I square root 3 over 2. And I can write this as negative 3 minus 3I square root 3 over 2. So complicated in the answer, but doable. So let's kind of just review a little bit. Whenever I have something that's some value cubed, plus or minus some value, I'm always going to get one real zero. This part of the formula is representing, sorry, I should do that in blue. This part of the formula is showing us that real zero. The second part of the formula is going to help us find the non-real zeros. We have to use the quadratic formula to do that. When we use the quadratic formula, we have to remember that the square root of negative 1 equals I. And we have to remember how we can simplify